is Yari, and I work for Finn in Norway. I'm the creator and maintainer of the Ruby bindings for WebDriver. I'm going to talk today about WebDriver Internals, sort of a technical description of the application.
So I know it's late in the day, and this is a fairly technical presentation, so I hope you will not fall asleep. We'll see. So, who am I? I work as a senior test engineer for Finn, which is a Norwegian classified ads company. Basically Norway's largest marketplace, sort of similar to Craigslist or eBay. I work for the engineering productivity team, which is a small team focused on testing and developing tools and in general just improving the development process. And Finn has about 4 million unique users per month, which by Norwegian standards is pretty good. You can also find me at these places. I do a lot of open source projects, mostly in Ruby. I'm the creator and maintainer of the Ruby bindings for WebDriver, which is, I think, just about to hit 1.5 million downloads. So that's pretty cool. I've been working on WebDriver since 2009. And yeah, just lots of Ruby code. So David sort of covered part of this, but I'm going to give a short history of browser automation. Before I do that, who here, just a raised show of hands, who uses the RC Selenium 1 API? The Selenium RC API, Selenium 1? And who's using WebDriver? Okay, so most of you are already using WebDriver, that's good. So, sort of the simplified overview. In 2003, Brett Petcord created Watir at TalkWorks, and it uses Ruby's standard library to talk to IE via COM, the COM OLE bindings. And Watir had a really nice API. It was the first real browser automation tool, and it had native control over IE. But it was Ruby only, it only supported IE, so it was Windows only, and the internal code was not really nice. But the API is nice. So around the same time, in 2004, Jason Huggins, also at TalkWorks, introduced Selenium, which was inspired by Fit to test in-house time and expenses app. And Selenium has this table-based syntax, which is what is inspired by Fit. They also use the same format to specify tests. And this is what's called Selenium Core. And the fact that tests are written in HTML makes it allows people that don't really have software development experience or programming experience to develop tests. It soon became clear that maintaining large test suites in HTML is not really ideal. Also, being written in JavaScript meant that cross-domain policy prevents the test from moving from one domain to another. So, the solution to this problem was to introduce an HTTP server in the middle. So everything is routed through a proxy. Also the requests made from the browser is going through a proxy and back to the application. Basically intercepts all the requests from the browser to your application. Which is sort of complicated, but it opens up the possibility of writing Selenium bindings in multiple languages, because you have the server that you can just call with HTTP, and all languages know how to speak HTTP, so that's quite nice. And this is what's known as Selenium RC. So the Selenium 1 has some benefits. It's cross-language. The core is written in JavaScript, so it's quite easy to work on, and it supports all browsers in theory. but it's at the same time restricted by the JavaScript sandbox, and it has a bloated procedural API and quite complicated architecture. You've probably all seen this. And when I say the API is bloated, I'm not kidding. It's grown organically over time. It's a single interface with dozens of methods, and all of them take string arguments. It's quite huge. And also multiple methods that do almost the same thing, which is sort of the prime example of how to not design a good API. So, the RC protocol, the HTTP mapping, is basically makes an HTTP call for every command in the API. So it uses the query parameters on this URL to call out to the server. And the API is very thin abstraction above the actual HTTP calls. It's not really an abstraction at all. It's just a mapping to URLs. And then, in 2006, Simon Stewart created WebDriver. And WebDriver has the benefit of hindsight in a lot of these issues. So one of the explicit design goals is to have a small object-oriented API and use native code where it's needed and JavaScript elsewhere. Still leverage HTTP as a transport. Still keep the language support. And still pretty decent browser support. So when you look at the WebDriver API, you compare it to the Selenium API, it's just a lot more simpler and object-oriented. So yeah, I think it's obvious which one you want to use. And WebDriver isn't less capable. It basically has the same capabilities, it's just a more succinct API. And one of the interesting developments since 2009 is that these tools are all consolidating on WebDriver as the underlying technology. So we now have Watir WebDriver and Selenium 2, which are both using the same tech. And that's a good thing, because automating browsers is quite hard. So let's just do it once and then build nice abstractions on top, if necessary. And there are new tools popping up as well, like Jen, which is a really nice Ruby DSL for writing web tests. So that's sort of the history there. I'm going to talk about a few architectural themes in WebDriver. They are emulate the user, prove that the drivers work, that you shouldn't need to understand everything to develop WebDriver, and that every API call is also an RPC. So first, WebDriver is designed to accurately emulate the user's interactions. So that means, if possible, we'll use native clicks, native keystrokes, but try to still keep it simple to maintain cross-browser and cross-OS. And the API should sort of be at that same level that the user would interact with the application. So, for example, there's no fire event in WebDriver. And that's because fire event usually in other tools is a workaround for a bad click implementation. If you can't click properly, then you need things like fire event. We would rather fix the click implementation than grow the API with things like fire event. Next point is about proving that the drivers work. So WebDriver has a quite extensive automated test suite. Most of them are integration tests. I think there's about 700 in total. There's also a strong culture among the development team to add tests when we're fixing bugs. Setting up CI for this kind of thing is quite challenging. We want to ideally test all 6 browsers on all 3 OSs with all 4 languages, which would end up with about 72 builds per commit. We're not quite there yet. We have a CI system that's working quite well, but it's doing like 50 builds, so still some way to go. Next point is about you shouldn't need to understand how everything works. There's lots of languages and technologies in use in WebDriver, and we really like to have an architecture that will allow developers to focus on the things they know really well. So that means we want to separate things so that if you know Ruby well or you know Python well, you can focus on that. And you shouldn't need to understand how the full stack underneath actually works. And the last point is that every API call is an RPC. Since WebDriver has the need to communicate with external browser processes, every API call you make is actually a call out to the browser. So that means the performance of WebDriver is sort of at the mercy of network latency. Usually it's not really noticeable. Most operating systems will optimize localhost network action, but in some cases it sort of introduces tension into the API design. Should we make really coarse functions that only do one call, or should we focus on expressiveness and ease of use? Right. So internally, WebDriver is sort of compromised over 4 layers. We've already seen the API. We've already used the API. Underneath the API sits a service protocol interface, which is basically a set of command and response mappings. Basically, it's the object-oriented API flattened out into a procedural API. Underneath that is a JSON wire protocol, which is sort of the reference implementation of how the SPI works. And beneath that, the browser. So the API is the user-facing side, and the SPI is the implementer-facing side. So usually, as a user, you need to care about anything except the API. But under the hood, there's things going on. So like I said, every API call is mapped to a command and response. So for example, a find an element call would yield this pair. And what's happening here is it's sending a command called find_element with a set of parameters, and it's getting a response back. The status is 0, which means success, and it also gets back this OK element identifier, which is then being used for later calls. For example, when it's here called sendKeys, it will just pass along the same identifier and receive a success response back. Another important difference is that the API is object-oriented, but the SPI is procedural, because it's basically meant to map to a remote procedure calls underneath. So the SPI is basically a flattened version of the API. So you see the web element abstraction is totally missing. It's just IDs being passed to functions. So that's one way to divide the sort of top part. Another way to divide it is look at what is being standardized, like David talked about, and what is being kept in the Selenium project. So Selenium, or the WebDriver browser automation standard, is compromised on the API and the SPI, and Selenium is sort of the reference implementation in spec terms. Underneath the wire protocol, we have what's called automation atoms, which I'll talk more about, and then the browser. So, like I said, the wire protocol is the reference implementation of the service provider interface. And it's not actually a requirement for implementers to do the wire protocol, but they will get a lot for free if they do. If you want to implement WebDriver for a new browser, if you stick to this protocol, you'll get the existing language bindings for free, for example. So, given all these languages and all these browsers, the most natural choice as a way for them to communicate is JSON over HTTP, because it's ubiquitous and all the languages supported and all the browsers supported. So the language binding acts as a client, and the browser acts as an HTTP server. And this has some nice properties. You can run this locally on your own machine while you're developing the tests. It also scales out to calling out to a browser on a remote machine. So the test still runs locally. It's using the same wire protocol. It's basically just a dumb proxy in between. It just pipes the commands to the browser. And it scales also up, of course, to a grid system. So you could have a cluster. And the wire protocol is basically a mapping of the SDI commands to a sort of REST-ish API. So new session is a post with what kind of browser you want. Find element will then pass along with this session ID and the parameters and as a JSON body. And sending keys is post to another resource. So yeah, fairly straightforward. And the JSON wire protocol is very well documented. So if you want to, I think someone asked earlier about developing clients for new languages. It's quite simple to do. You just need the ability to create it or do HTTP calls against the server and just implement this protocol. Creating a new driver is a little more work, but it's sort of well defined what you want to do, and you can reuse the existing test scripts if you go with the wire approach. So, underneath wire protocol, we have a library of JavaScript, which is called the automation atoms. It's developed using the Google Closure library, and it's compiled. They have quite advanced compilation, so that you can compile it down to whatever format you need. So even if the driver is written in C++, it's compiled down to a header file with scripts that will be injected. And the compilation is smart enough to know that, okay, I'm running in Firefox, I can remove all the branches for Chrome or IE. So you can compile down IE-specific atoms, and it takes out all the code that is specific to Firefox. So it sort of works like this. We have the atoms library and the Closure compiler, and it's in different formats depending on the driver. And this makes it really easy to share code between drivers. So instead of having to re-implement things that basically are easy to do in JavaScript, we can just have this shared code base that works across each driver. So we also then only use the native capabilities of the browser if we need them. Otherwise, we want to sort of maximize for ease of development by using the JavaScript atoms. Yeah, this is get visible text. It's sort of a quite complicated algorithm to get visible text of an element You don't see the full thing here because it calls out to other functions. But having this shared among the implementations makes sure that you will get a consistent string back for all browsers. So I'm going to go through each driver and show you sort of how it works. The Firefox driver is implemented as a Firefox extension, which means that all our code live inside the browser process. So we actually have a small HTTP server written in JavaScript that's running inside Firefox, which ends up calling out to a dispatcher and then call down to the atoms and ends up talking to the Firefox APIs. So most of the Firefox driver is basically JavaScript. There's some native code, but it all lives inside the extension. The Chrome driver is a little bit different. It's a standalone executable, which is written in C++. And it uses the Mongoose HTTP server. It's a small embeddable server written in C. And the best part is that the Chrome driver executable is maintained by the Chromium team. So we don't actually touch this code, except they sometimes import the JavaScript atoms from our code base. And ends up talking like a Chrome-specific IPC protocol called automation proxy. The IE driver is quite similar. It also uses Mongoose to provide the HTTP server. It also uses the atoms, but it talks common to the IE process. And we may move this to a standalone executable in the future. The Opera driver is written in Java, so it's using Jetty, and still the same atoms. But to talk to Opera, it's using protocol buffers, something they call the SCO protocol, which is specific to Opera. Alright, I'm quite ahead of time. Do you have any questions so far? Yes? Sorry.
You have we have one interface, WebDriver, and we have several implementations. Am I understand correct that WebDriver SPI and JSON Wire protocol are the same for all implementations, and difference are only on API level?
Currently, yes, you're basically right. Currently, the SPI is sort of the reference implementation of the SPI is what the Selenium code base is right now. So all the drivers use the Wire protocol to implement the SPI. But if a new browser comes along and they say, hey, we want to do this differently, but we don't want to use the Wire protocol, according to the spec work with the W3C, they're allowed to do that. It's a non-normative section.
Also, I have a question about Chrome driver. When you use it, you need to download a special edition of Chrome. Do you know why it's done in this way?
You mean a special edition of Chrome or a special edition of the Chrome driver executable, the server in between?
Chrome driver.
Yeah, so the Chrome driver, since it's maintained by the Selenium project, by the Chromium project, and it's quite big, like the executable, it could add like 30 megabytes to our package, which we don't want to do. That's sort of the main reason we have to download as a separate executable. But you have some trouble with versions, or?
We have a project that uses Chromium sources. And because it uses sources that don't have Chrome driver built in, we cannot work WebDriver with this.
Okay, because it's a standalone executable, we can't use the Windows service. Yeah, I don't know how to solve that. Sorry.
Do you know the the internal schema how mobile browsers are supported?
Yeah, it's the same. They still. I should have shown. I should of course have had slides for those as well. But it's the same thing. It's the same wire protocol. Both the Android and the iPhone driver embed a small HTTP server. In the case of Android, it's a small Jetty instance, a Java HTTP server. And in the case of iPhone, it's an Objective-C HTTP server. So it's the exact same mechanism. It's the same wire protocol.
But what is between browser and this HTTP server?
It depends on the driver. So in the case of Firefox, it's just using the JavaScript add-ons and then has some Firefox-specific JavaScript code, at least inside the extension. In the case of the iPhone driver, it's basically Objective-C, just a normal iPhone application that opens up a web view and then makes calls into that from the native code.
Hi. I have questions about drivers and especially it's about Safari driver.
Okay.
So what's the expectation or what's the bottleneck in implementation of the driver and so on? Thanks.
Yeah, I think the bottleneck is basically lack of anyone coming along and writing it and no interest from Apple in doing it. I know there's people at Google who are working on Safari driver this quarter. They want to have it done this quarter, or at least up and running. So maybe it will happen, I don't know. It's basically a matter of someone coming along and saying, okay, I want to work on this. So if you want to do it, you're welcome to. Okay, I have a plan to do sort of a demo and show you how to implement a new command in Firefox. WebDriver recently got the ability to resize windows and move browser windows, and we had a lot of requests to actually maximize the window. So I thought I'd show you how to do this. We'll start by doing it in Ruby and Firefox, and if there's time, which I guess there will be, you can do it in Java as well. So, what is happening here? Okay. So this is the Selenium tree, and in order to add this command, I would like to write a small integration test in Ruby. Here on the Windows spec. So I'm not sure if everyone has seen this, but you can do driver manage window, and you'll get an interface that lets you control the window. And I'm going to do this for Firefox. So I'm going to guard the spec. Oops, guard. Easiest way I can think of testing this is to just make the window really small and then assert that it became larger when I call maximize. I think at least that's good enough for now. We'll find out if there's edge cases later. So, on the second, we use new dimension. Let's say 200 pixels. And we want to maximize it. And we want to get the view size. And then just make sure it's larger. So let me run this actually. Right. So what it says is undefined method maximize for Selenium WebDriver window. So this is the window interface, the Ruby instance of the window interface that we got back from this call. So I'll find that. Let's see. It's this thing here. And you'll notice this has a private constructor that takes in this bridge. And the bridge is basically the flattened API, basically an implementation of the SPI. So what we want to do here is just delegate down to this bridge. So the bridge sort of has this procedural API. And if I were to run it again, it would fail that there was no maximize window function of the bridge, so I'm not going to bother with that. And this is basically the whole WebDriver API flattened out, so it's just a procedural version. And here, we want to add maximize window. And yeah, actually we want to, potentially in the future we want to be able to resize or remove or maximize any window, but currently we just pass in this current Selenium value. It's just a detail. So, let's try this again. I must have made a typo. I forgot to save the file. Alright, so now it says unknown command maximize window. So now we get into the layer where it maps these bridge commands to the actual REST resources. And that's in Ruby, it's in a single file. Here. So that's basically the full API mapped to URLs. And yeah. You want to make this a post against same as this resize and move things, but just call it maximize instead. So now basically the Ruby client side should be okay, and we should get an error from the server inside Firefox. Yes. Unrecognized command post, blah blah blah. Basically a 404 response from the Firefox server. So, in the JavaScript folder, a folder called Firefox driver, and it has this dispatcher component that I think I showed before. Which basically just sets up how these URLs are dispatched to commands on the Firefox extension side. So what I want to do here is just add a new binding. Now we should get a different error. And it needs to compile the JavaScript because I changed it. Right, so you can see from the stack trace that it's now failures from the server, and it says unrecognized command maximize window, because I haven't had this anywhere. So this should go in the Firefox driver, and the Firefox driver is again, again the same command mapping, but here's the actual implementation. So every function here takes a respond, which is the response that it will send back to the server, to the client, and a set of parameters for the command. So we take, let's see. Find somewhere. Alright. I want to reuse this, and just since we don't currently have the ability to resize arbitrary window handles, we just want to assert that this targets the current.
Wrong parameter.
Parameter, thank you. And at the end here, we want to send the response. Otherwise, it will just hang because it's asynchronous, so we just call respond. So here we want to do the actual implementation, and this is where we want to call down to the atoms library. So we want to implement the actual code to maximize the window inside the JavaScript atoms, and then call those from the Firefox driver. So here, first I want to get the current window from the current session, and then just what window maximize and pass in the window. So all these bot things are part of the JavaScript atoms. So basically we're done with the Firefox specific parts of this. So in the atoms code there's a window file which has window stuff. Actually, let's see the documentation right here. Same logic here. If we're not past the window, we just want to use the default one. So to maximize the window, there's two things we want to do. We want to move it to the top left corner, and we want to make it fill the full available space of the screen. Anyone know how to do that in JavaScript?
Set avail. Set avail.
Yeah, close. Screen dot available width and available height will give you that. So we have on the window there's a screen object which has available width and screen avail height. And to find the top left position, which actually on OS 10 it's because of the top menu, it's a bit below, it's not 0, 0. That's also available there. So it's wing, screen, avail, top, wing, screen, avail, left. And since we're using this Google closure things, we want this as a coordinate instance. And we want this as size. So since we already have these functions to set the position and the size, it's just a matter of calling those. Okay. Looks good. Let's see. Yeah, it needs to compile some more JavaScript now because I changed that thing, so can take a while. Sure.
Could we just pass this JavaScript through JSON wrapper?
You could, but in some cases it's a nice thing to be inside the extension, both for speed and also because the ability to actually move and resize the window, it's not any longer available in JavaScript. So Firefox and Chrome has disabled the ability for you to do that inside the page because annoying pop-ups will do that quite often. So that's actually disabled, but since we're inside the extension, there's a different security context and we can still make those calls. Yeah, compilation can be painful. Any other questions? Now we're waiting.
Will we commit these changes today?
Committed today? Yeah, why not? You need it? For Java. Okay. Yeah?
Yeah, I got one. So, what is nowadays, what is the difference between Watir and Selenium, if there is any at this point?
It's just at the API level, basically. So, it's just two different APIs. The Watir API is slightly higher level than the WebDriver API. Apart from that, it's all the same technology underneath. So
basically, you can change one over to another.
yeah, except you'd be coding against two different APIs, so it's not just a switch. Oh yes, it worked.
You change this, like define this method for Firefox only.
Yeah.
So to commit like a final.
To commit like a final version, you need to extend it with IE as well, right?
Yes, and this is sort of where the different people on the team step in. So if I commit to Firefox implementation, I'll go to Jim Evans, who is the IE maintainer. I'll tell him, hey, I've added this wire call. Can you add it to the IE driver? I've already done the add-ons. So we can just use the same. Ideally, I'm not sure if it's possible in IE, because I don't really use IE. But ideally, this code isn't Firefox specific at all. It can also run inside IE. So I'll just tell him, okay, here's the wire call, and here's the atom, and he can make it work in IE. And the same thing for the Chrome people, since that's a different team. Yeah. All right, so we got it working. Good.
Great.
So. Yeah. I think everyone's tired. I'm a bit tired. I don't think I'll do Java. Unless you're really interested. No. Okay, so just questions then. Anyone? No? I have a few slides. So if you want to contribute to WebDriver, there's a few tips. One of them is ask for help and input early. We have sometimes people come with like they've done 3 days of work and here's my patch, and it's really hard to integrate. Either because they've done something that sort of isn't the right way to do it, or just because it's too big to actually review. So join us on the IRC channel and talk to us during, hey, I'm going to implement this, I'd like to implement this, how should I do it? Just keep the feedback loop really short and write tests, please. And if you want to talk to us, there's the Selenium developers mailing list, and we're all on the IRC channel all the time, most of us. The code is on Google Code, and there's an issue list which has, some of the issues have this getting involved label. If you find those issues, those are good starter issues if you want to get involved with the code base. Yeah, that's what I have. Thank you.